Hello guys, my name is Arun and welcome to my channel. This is actually a series of non-standard videos from Python, so hence they come under the name Python hacks. Now in this video series, what I'm going to do is that if I find something interesting in Python, or in collab or something that can be done using Python in collaboration with some other programming language or some kind of highly advanced stuff which did not take which were not a part of my actual Python programming series which I have along with me. They'll be going to be posted here, and that will be very helpful for you guys in the future as well. I hope so. Okay, and unlike the previous series which we have in Fortran or Python, this will be a non-standard series wherein those are like courses, whereas these are like some special topics discussion, special topics like that. So with that introduction setting in, let's talk about today's topic. And in today's topic, I'm explaining you guys about f2py. Now, f2py is actually a NumPy module. Is actually a part of the NumPy module right now, but some time ago it was a separate module. And what it does is that, as the name suggests, it helps to convert Fortran files into some kind of files that can be used in Python. Now, here's the thing. Suppose if you guys are working in Python for Fortran for quite a long time and you want to use them in Fortran, let's say, sorry, if you guys are working in Fortran for a long time and you want to migrate to Python, but you have like a lot of Fortran files available, and you don't want to convert all of them. It'll be very painful to convert all of them. On the other hand, if you use your Fortran file, get some kind of intermediate files from them, which if these intermediate files are something like how Fortran Python can use them very easily, won't it be very easy for you guys to get your job done? Okay, and that's what f2py does. f2py takes your Fortran modules or Fortran files and converts them into Python modules, which can later be imported by Python and used inside Python just like any normal Python file, very seamlessly. And now, why is it useful? Is for this reason. Fortran is a compiled programming language, and as a consequence of that, it's super fast and does a lot of extremely complicated computer-intensive operations very quickly. On the other hand, Python is a highly advanced programming language, which has a lot of freedom, and it can do a lot of fancy stuff very quickly. But it compromises on the speed. Imagine a way that you get the best of both of these languages together. You get the speed as well as the speed as well as the freedom and elegance of Python in a single way, in a single kind of synergy. Now that's where f2py works very well. Now what you can do is that with f2py you can just write a Python code such that it does all the operations, and wherever if you come across some computationally intensive regions, pass those kind of tasks to Fortran files, and get the jobs done from that. And then when you have some fancy stuff to do, let Python do all the jobs on the head. It's like Python employs Fortran as some kind of as its employee, and does the overall job. Python behaves like a manager who does the overall job, and the Fortran behaves like an employee under the manager, or like a personal assistant under the manager to do some highly intensive highly intensive jobs and in a very quick manner. Simple as that. That will be really useful because it saves you guys a lot of time. It will save you guys a lot of time, and also it'll make you get your job done much better in a much elegant way. Now that's the advantage of f2py. Now to install f2py, it's fairly straightforward. If you guys have your numpy program installed along with your Python distribution bundles, then it's taken care of. f2py is by default available in them in the latest version, so it's not a problem. Okay, earlier you had to install the f2py separately. Now we don't have to, so that part is taken care of. Now let me explain the concept today. Now I have like 4 files over here. This is the text file which I showed you, and you have a Python file and a Fortran file over here. Now this for Python file is fairly straightforward. I just have just as a numpy module here. It imports a numpy module here, and FYI, if you guys must know you guys must know some basics of Python and some basics of Fortran to understand what's going on over here. Otherwise, you guys will be like totally lost. Okay, just just so that's just a check so that you guys know what you're looking at. Anyway, coming back, I import the numpy module here. I import this time module for a particular reason, and then I'm importing the matrix Fortran the compiled module of this Fortran file here. Now, this compilation I'll tell you guys in a minute as to how this happens. Okay, just going along with, just go with the flow with me. I'll explain. I'm just creating three variables, m1, n1, m2, and n2 for some with some values, and then I'm using these values. I'm creating three empty arrays A, B, and C. Okay, we're going to do a classical matrix multiplication problem as an illustration for this f2py operation. So we're going to use that. So, and then what I'm going to do is in these lines I'm just setting the value of A and B with some random values using the random function in numpy. And then here's the important line. This is actually the Fortran call, and this is actually the function call. Now in this Fortran call, what I'm going to do is that it has 4 lines. This line, what it does is that it just, the function time calculates the time elapsed from some reference time in the past till a particular time. So for instance, right now it's 1:54 in the morning with 5 seconds past. Okay, so with reference to midnight, it's actually 1 hour 54 minutes, and right now 15 seconds past midnight. So it's 1 hour 54 minutes and 15 seconds past midnight. Okay, so so that's what it's going to say. This function is going to say something like that. Now, but not with midnight, but some other reference point in time in the past. Okay, that's what this function does. And similarly, I'm going to use the same thing over here. And if you look at it, this is going to give us a reference point as to tell how much time that elapsed between for this operation to do. Now, if we just take the stop value and the start value and subtract them, the difference between stop and start will give me how much time in seconds it took for the operation about to take place. Now, since these values in seconds and this operation will be ending in milliseconds, so to give us a feel, I'm just going to multiply this by 1000. I'm going to write milliseconds. Okay, like that. Similarly, I'm going to do the same matrix multiplication operation using the Python file, using the Python module, the dot function available in numpy to do the same thing. And that's about it. And let me explain about the Fortran file. The Fortran file has only one subroutine as of now because it's a simple example. This has only one subroutine here, and this subroutine name is matmul1, and it takes 6 arguments. Now why 6? I'll explain. To calculate the matrix multiplication, I'm passing the 2 matrices and their rows and columns using these 3 variables. Okay, the result of the matrix multiplication will be stored in variable C. Now this is how it works in Python, but for Fortran to understand it, you just have to pass all the input and output arguments in the matrix, in the argument list in the subroutine. So I have to pass 6 arguments here, but in actuality I just pass only 5. Okay, and now to indicate that except C, all the 5 values are taken as input arguments whose value will not change when the subroutine is over. I'm indicating the keyword intent in, whereas using m1, n1, m2, and n2, I'm just setting the dimensions of A, B, and C to the telling the compiler explicitly the sizes of A, B, and C. And then since C value is not at all modified or changed or never initialized anywhere in this program, but it's going to get modified after coming inside the subroutine, I'm just giving this keyword intent out. If you guys don't know what exactly these keywords mean, just go and check my Fortran tutorials, or just check in the other tutorial series for Fortran. You will understand what's going on. And then I'm setting three values I, J, and K. I'm just setting three values I, J, and K for matrix multiplication operations. And then I'm going to do the classical matrix multiplication operation over here. As simple as that. As simple as that. Now if you guys notice, usually this I loop will be on the top, J in the middle, K at the bottom, usually in other programming languages. But for Fortran, for Fortran, these are mostly column sensitive. How do I put them? The values are like column major, wherein the memory allocations are, the column values are stored adjacent to each other. To keep that in mind, I'm just changed the order of this algorithm. But I guess this will give us the exact same result, so it's not a problem. That's about it. And now let's look at the operation. So if I just press ls, I have my 4 files ready. Now here's the thing, I'm using Python. I'm using Anaconda Python. So if I just type Python, the default Python available in my system is Python 3.5 from Anaconda Python. Okay. Now on the other hand, the Ubuntu also has a system Python. Okay, so if you guys are just using system Python, you don't have to worry about it. If you just have NumPy installed along with your system Python, then everything is fine, no problem, no worries. It's taken care of. On the other hand, if you guys are using Anaconda Python like me, okay, you just have to do a small fix. Install NumPy for your system Python, as well. Reason is as follows. As of now, I do not know how to use the f2py that is installed along with Anaconda for the operation. I just don't know how. So I'm using a workaround by installing NumPy module alone in system Python. So when I call f2py, it's going to use the system Python's NumPy to do the operations. To get everything. But when I run the file, it's going to use my default Anaconda Python to get the operations done. So I'm using that way. I'm just using this kind of way. Hope you guys understand what I mean. Okay, and if you guys know any suggestions, like if you guys know or can figured out how to use the Anaconda Python's f2py as a system Python stuff, Anaconda Python's f2py as a system's default f2py, then let me know. That would be really helpful for me. Okay, now what I do is they just have to type f2py 3. I'm using Python. For if you are running Python 3, type f2py 3. Okay, and you have to install NumPy module for your Python 3 to get this job done, and then type -m, and then you type your module name. This module name can be anything, and just to keep the consistency, I'm typing matmul1 as it is, and then you type -c, and then you type your file name, Fortran file name, matmul1.f90. So if I press enter, it's going to do a lot of compilation. And let me clear this up, and let me push this on the top. And if I press ls, I'm going to get this shared object file .so, but it has a really long name. So what I'm going to do, I'm just going to rename it, and okay. So if I press enter, it's renamed. Now to use this in the Python file, it's fairly simple. We just saw this line. You just have to import the file name directly. Import it just like that, and that's it. Now once the importing is done, we may just execute this Python file. The importing will be done automatically. So just watch. Python startup py press enter, and that's it. Simple as that. And absolutely simple as that. You have your results ready. Now if I just go down, this is what it happened. If I run this again, this is what it happened. It says that Fortran took like 4 point something milliseconds and NumPy took like 5 point something milliseconds to do all the operations and everything. Okay, to do the operations and everything, simple as that. Now that's about it. And if you want, I can just copy this. I am doing this is as follows. I'm just resetting the value of C to be empty so that everything is going fine. And there you have it. Whoa, that's fairly close. Fairly close. Fairly close. Now if you just run the same file again and again, you'll get to see that for different random values, your Fortran and NumPy gives you your Fortran and your NumPy module of your Python. They just work out nicely. Now what I'm trying to say here is as follows. If you just look at this, sometimes the Fortran module is extremely fast and it works nicely, as in this case. Your Fortran file, sorry, not this one, like this one. Your Fortran file took like 3.97 milliseconds to do all the multiplications. On the other hand, it took like 17.1 milliseconds for your NumPy, which is actually your Python, to do the same matrix multiplication. Okay, sometimes your Fortran took like 8 milliseconds something, whereas your NumPy took like 1.3 milliseconds something. So you might ask me, hey, why on earth you say that Fortran was fast, right? Then how come it's slow? It's in the same order of magnitude like that of NumPy. Well, my friend, the reason is as follows. NumPy is actually built on Fortran files under the hood. So if NumPy subroutines and functions, they use Fortran under the hood for their own options. So you're getting a similar speed up like this. But just a reminder, if you guys are going to use a lot more complicated options in the past, in the future, you're going to build them using NumPy modules, so that output result will now be optimized like that of in Fortran. So that's the reason. And if you guys notice one more thing, I just have to compile I just have to compile this uh, Fortran file only once, and after that I was able to use them again and again seamlessly in Python, and that's the advantage you get. I don't have to compile this Fortran file again and again in Python. I just have to do it once and that's it. Now let me clear this up, and that's how we use thing. And if you guys want, if you go on, if you can just play around with it, and let me just mess this big time, and if I run this Python file again, now it will take time. It says Fortran took about 469 milliseconds to do the option, whereas NumPy took 50.48 milliseconds. Run this again. Run this again. Oh, okay. That's fairly consistent. Now, anyway, what I'm trying to say is that like this matrix multiplication operation is completely optimized in NumPy using in this because of this dot function is completely optimized, and moreover, so you might get speed differences. Guilty for that, but trust me, if you guys want to use some other operation, they'll be extremely good. Okay, and if you guys don't believe me, okay, instead of this, I can use, instead of NumPy, let me do something a little different. Let me copy the same thing again and paste it over here. Now let me do the same operation like what for I in range 0 0 0 to what is it, m1 for j I think I don't need this. Okay, I think I'm for j 0, 2 and 2, for k in range 0 to m n1 m2 c I comma j plus equals a I comma j I comma k multiplied by b k comma j. And that's it. Now I can say this as for Python using Python. Now if I were to run this, please don't kill me, please don't kill me. This is going to take a lot of time, for definitely. Hopefully it works quickly. Please, I'm gonna have that much time here. Now you can clearly see that Fortran is taking time. NumPy finished. Fortran finished quick. Finished in 470 odd milliseconds. NumPy took like 50 milliseconds, whereas your actual Python is taking more time. Now I think I'll just cancel this. I'll just use some simple values for. I'll just reduce the task time it takes. Yeah, I'm just saying that Python like Fortran took like 0.1 millisecond, NumPy took like 30 milliseconds, Python took like 0.43 milliseconds. So if I would run this again, something of the same order, but Python took like largest time. You can clearly see this routine, this routine is actually purely Pythonic, and it took the largest number of time, whereas your NumPy and your Fortran, which are actually made from highly optimized Fortran, this module is not made from optimized Python but Fortran, but reasonably, but this is actually made from a completely optimized Fortran code, so it works fine, and that's how it is. As a reason, these two are faster, whereas this one is orders of magnitude slower. Now I think now you'll get an idea what's happening, isn't it? You'll get an idea what's happening. Now if you want to do this in Python 2 series, it's also possible. Now for that, what you have to do is that you just have to change the default. You have to do the same thing, but you just have to type f2py, and that's it. f2py, and the same thing as follows. So what I'm going to do is that I just written a small shell script for me. Okay, I'm just going to remove the object files and shared object files if there are any, and then I'm going to compile this using Python 3, rename the file, and just going to type saying running in Python 3, and then going to do that, and then I'm going to run this in Python 3, and afterwards I'm going to remove this. I'm going to compile this file with respect to f2py Python 2. This is through Python 2, and in my system I have Python 2 as well. I'm going to activate that by using. I'm going to make that as a default Python for temporarily Python using this command. If you guys followed my Anaconda Python series, you'll understand what I've done. If you follow my scientific programming series in Python, you will understand. And now I'm running this in Python 2, the same command, and then I'm just reverting it. Now if I just let me clear this up. Now if I want to do the same thing in Python 2, I just have to write f2py, and that's it. And just like in my usual case, I do not know how to make f2py available in Anaconda Python as the default f2py in my system, so I'm just using the system defaults numpy thing to do it. Now let me run the shell file, and if I press enter, it does a lot of operations. has a lot of operations, and you get a lot of it. So I'm just going to pass this to log.txt, all the output to this file log.txt, and if I just open that log.txt file over here, open with Genie, and it says these are just building files and everything. All these are just building files, and the actual operation takes place. Okay, now where is that? Hmm. These are the outputs. Yeah, this is it. This is the output. This is the output we get during the compilation and using Python 3. The Fortran module took about 0.075 milliseconds to do the operation, whereas NumPy took 0.063 milliseconds to do the operation, whereas Python took like 44.4 milliseconds to do the operation. Okay, and after this the compilation started. After this the compilation started with respect to Python 2, and does the same kind of similar operations, and then we just shifted to run Python 2, and it does the same operation. When you do the Python 2, the Fortran took like 0.12 milliseconds, NumPy took like 0.19 milliseconds, and Python took like 84.4 milliseconds to do the operation. This way you know how to do the same operation in Python 2 as well as Python 3. And that's how you guys use f2py. Now in some other explanation and program, I'll explain you guys to do this a little more in elaborate manner, with a little more of a complicated example. And now with this, you guys must have clearly understood that regardless of which Python you use, whether you use Python 2 or Python 3, you guys will know how to use NumPy, f2py very clearly. Now that's all I have for you guys in this tutorial. Thank you guys for watching, and I'll see you guys next time. So with another interesting topic. Till then, take care. Bye.